In today's topic, we have addition and subtraction of numbers in standard form. Adding and subtracting numbers in standard form. Let's use the following example to explain the concept and the steps involved in adding and subtracting numbers in standard form. Look at the example. 5.6 times 10 raised to the power 5 plus 2.3 times 10 raised to the power 5. When adding or subtracting number in standard form, the first thing you check is the powers of 10. The powers of 10. Check whether they are the same. They have to be the same. If they are the same, what you then do is to add the decimals. So we're going to add, the second step is to add the decimal because our power of 10 is 5 here and it's 5 here. So they are the same. Let us add the decimal, 5.6 plus 2.3. Let me add it. So in adding the decimal, 6 plus 3, 9. And put our point, 5 plus 2, 7. So our decimals have added it is 7.9. So our final answer, what we do is to write this 7.9 times 10 raised to the power 5. You have to leave the powers the way they are. Since they are the same, they have to be the same for it to easily add. So remember to add or subtract numbers in standard form. First of all, check the power of 10 whether they are the same. If yes, add and subtract or subtract the decimals. Then write your number, your answer in standard form. Very, very, very simple. Let's take a look at this example. Look at this example. 5.5 times 10 raised to the power 6 minus 3.1 times 10 raised to the power 6. Remember, the power of 10, they are the same. So what do? We subtract the decimal. So I would rather say, I will now do 5.5 minus 3.1. So 5 minus 1, 4. 5 minus 3, 2. So subtracting the decimal, we have 2.4. And now remember our power of 10 is 10.6. So our answer becomes 2.4 times 10 raised to the power 6. 2.4 times 10 raised to the power 6. Very, very simple. Very, very simple. Checking the power of 10 is important. And then subtracting or adding the decimals and bringing down the power of 10 to the answer. That makes it correct. Let's do further examples. Look at this example. 3.5 times 10 raised to the power 4 plus 4.2 times 10 raised to the power 3. Can you observe that the powers of 10s are different? This one has raised to the power 4, while this one has raised to the power 3. So you cannot just add this and this. You have to first of all bring two of them to the same power. So when I look at this number, I can rewrite one of them to have the same power. This 4.2, I can write it in a way that it will have a power of 4, and that will not change its value. So I'm going to change 4.2 times 10 raised to the power 3 to give me a power of 4. And if I want to write that down, that means 0.42 times 10 raised to the power 4. 0.42 times 10 raised to the power 4 is the same thing as 4.2 times 10 raised to the power 3. 0.42 times 10 raised to the power 4 is the same thing as 4.2 times 10 raised to the power 3. How do you know? You can convert 0.42 times 10 raised to the power 4 to ordinary form and convert this one to ordinary form. You will see that it's going to give you the same answer. Let me convert 4.2 times 10 raised to the power 3 to ordinary form to show you what it will be. 4.2 times 10 raised to the power 3. That means the point moves 3 places. 1, 2, 3. See where our point will be. And I'm going to fill this place with 0. We did it in our previous lesson. So the answer will become 4,200. Now let me convert 0.42 times 10 raised to the power 4. Let me convert it here. 0.42 times 10 raised to the power 4, meaning that this point is going to move 4 places. 1, 2, 3, 4. So the point is going to be here, and the empty spaces I'm going to put 0. And remember, the point has shifted from this, so we have 4,200. Can you see that 0.42 times 10 raised to the power 4 is the same as 4.2 times 10 raised to the power 3. So now having converted 4.2 times 10 raised to the power 3 to 0.42 times 10 raised to the power 4, you can see that the power of 10 here and here is now the same. We are going to add 0.42 plus 3.5 because we're going to add the decimals. We have 0.42 plus 3.5. So I bring down my 2. This is 9. And this is 3. This becomes 3.92. So having added the decimals, I can now put the power into 4, 10 raised to the power 4. So my final answer will become 3.92 times 10 raised to the power 4. This is the final answer. Remember to always change the powers to be equal before you add or subtract. Look at this next example. 9.1 times 10 raised to the power 7 minus 6.5 times 10 raised to the power 6. Checking the powers of 10 are not the same. So I'm going to make them to be the same. And most often, the one that have the lesser number, the power is lesser, you can convert it to the bigger number by simply adding 0 at the back, that is to the left of the one that is having lesser power. So for me to change this one, 6.5 times 10 raised to the power 6 to half power of 7, what I'm going to do is to write it like this. 0.65 times 10 raised to the power 7. By moving this in this way, I have changed the power to be power of 7. And if I convert this one in an ordinary form and I convert this one in an ordinary form, it will give me the same thing. So they mean the same thing, but written in different ways. Now that I have converted it in the same power, I can now subtract. I can now do 9.1 minus 0.65. 9.1 minus 0.65. The way we normally do our subtraction. Since nothing is here, it is 0. 0 minus 5, it cannot go. I put 1 here. 10 minus 5, it's 5. And here is 0. 0 minus 6 cannot go. I borrow 1 from here and put here. It becomes 10. 10 minus 6 is 4. And I put my point. What is remaining here is 8. Because I borrowed 1, this becomes 8. 8.45. So 9.1 minus 0.65 is 8.45. Now I can write the answer using the power of 7. So our final answer is 8.45 times 10 raised to the power 7. 10 raised to the power 7. This is very, very easy and simple. Keep practicing, keep preparing this video until you perfect it. And solve the exercises that follows this video in. And see you in the next lesson. Bye.